going on, folks? All right, let's see. What is this? Okay, cool. Some of this is going to be review for you guys, but what I'm going to do today is I'm basically going to, what am I going to do? Oh, yeah. I'm basically going to go over some of the concepts you're going to see on some standardized tests, on the ACT or the SAT. So these are some average things you're going to see. A lot of this is probably from Algebra 1, but some of it is from Algebra 2. I'd actually say most of it is from Algebra 1, to be honest with you. But I'm just going to go over a bunch of example problems and kind of remind you, hey, you guys remember about remainders? You guys remember remainders? That's good stuff. All right, so a remainder. Let's see. Let's find a good problem for a remainder. All right, here we go. You have, if m minus n equals 5, m minus n equals 5, and 2m plus 4n equals 16, then what is m plus n? No. I mean, you just got to remember how to do this problem. All right, so here's how I would attack this problem. I actually showed you how to do this problem before. If you change these things to x's and y's, then really this is an expression for a line, and this is an expression for a line. And do you guys remember where we had that thing where lines cross? Where do the lines intersect? Yeah, that's exactly what it is. So say that you replace the m's and n's with x and y, and then you just basically say, well, where do they intersect? Well, you give me a x coordinate where they intersect, and then you basically give me a y coordinate where they intersect, and then you add those two together, and that's your answer. I think that maybe there's a trick to solving this, to be honest with you. And do I know the trick? Yeah, I know the trick. But will you remember the trick on your test? I don't know. So I'm going to tell you what. I'm going to do it the most basic way I know how to do this. Cool? Now, one way is to do the substitution method. You guys remember the substitution method where you basically go, all right, I'm going to take this guy and make him m equals 5 plus n. All I did was I kicked that n over to the other side. And then what I do is I rewrite this thing right here, but instead of placing an m over here, I'll replace it with what it is, 5 plus n plus 4n minus 8 equals 16. So I rewrote this thing, but I replaced the m with what it was equal to. We cool? Vaguely remember this thing. And now you have one equation, one unknown. You're good. You can solve this thing all day long. Got it? That would be what, like 20 plus, oh, I'm sorry, not 20, but 2 times 5 is 10 plus 2n plus 4n equals 16. So 6n equals 6, so n is equal to 1. Are we cool? And if n equals 1, then m must be 7. No, m must be 6. Because 6 minus 1 equals 5. We cool? And then what you do is you just say, all right, well, then m plus n has to be 7. Answer 7. We good? Now that's the substitution method. It's not the prettiest way. It's not the easiest way. But I think it's a very safe way, for sure. Yeah. I think that maybe one of the ways that you remember this is the addition subtraction method, where we said, all right, well, what I want to do is I'm going to add these together so that one of these guys cancel. So then I say something like, I'm going to multiply the top by 4. So I got 4m minus 4n equals 20. You guys see what I did there? I'm totally allowed to do that as long as I multiply everything by 4. And then I have 2m plus 4n equals 16. Now, ask me, why did I multiply the top by 4? There we go. I multiply the top by 4 because I'm looking at this and I want to cancel out this 4n with that 4n. That's why I chose 4, because there's a plus and a minus. I mean, I could have multiplied the top by -2, and then I would be able to kill the m's right off the bat. It doesn't really matter which one you go for first, as long as you get both of these things. If I add these straight up and down, this becomes 6m equals 36. Therefore, m equals 6. And if m equals 6, then n equals 1, and then you can add them together and blah, blah, blah. Are we cool? So you guys remember how to do this. Remember, when we were solving, like, where do the lines intersect? We did 2 methods. We did the substitution method, and then we also did the addition-subtraction method. So I showed you both of them. Got it? Oh, I'm sorry. That wasn't on remainders. This was on simultaneous equations. Sorry. I'm looking at the wrong section. All right, we cool? You guys want to know, there is a trick to solve this problem really quickly. I'll show it to you real quick. I don't expect you guys to remember it. I'll tell you what. I have all of the old videos from semester 1 still posted to the class. I just have them all hidden. Do you guys want me to unhide them so that way you can at least see the old videos? I can do that. It just makes, all it does is it's going to make the class really big, as far as, like, you're going to have to scroll down a lot to find your homework. I'll take a vote in class. What do you guys want? I want more than just Lucas and Sophia to answer. Do you want me to unhide all of the old videos that I have? Okay. Come on, I need more than 2 people to talk. 3 even. A little bit at a time. All right. I'll unhide it, but I'm just going to send out an email as a warning. Hey, look, the class is going to look huge. It's because all of these past, whatever might be in the class, but don't get freaked out. All right? All right. By the way, the quick way to solve this one, there's a trick right off the bat, and I'll show it to you. If you add these up, this becomes 3m plus 3n equals 21. And then divide by 3, you have m plus n equals 7. Boom. Done. But I don't expect you to do that way. I totally wouldn't memorize this or anything. I'm just showing you there's a little trick to do it. There's only a trick to do it because it just so happens to work out that way. What I would do if I were you is, if you want to hit simultaneous equations, go back and remember how to do substitution method and addition subtraction method. Sure, those 2 methods take longer, but it's the correct way to do it, because this trick doesn't always work. In fact, this is one of the very few times where this trick actually does work. I didn't know you could just divide by 3 and cancel out both 3's. Oh yeah, Well, what I did, whoever asked that question, is I divided everything by 3. I'm allowed to divide everything by 3, as long as I do it to everything. Does that make sense? Or maybe it would be you would like this better if I factored out a 3. Now I can just divide by 3. Are we cool? Yes, can I move on? All right, good. There's a section that I'm going to write, and it's called symbols. I'm going to say weird symbols. You totally know how to do this math. The thing about this particular section is we throw in these weird symbols just to screw with your head. Because immediately, and this is what I see in physics all the time. In physics, we use a lot of Greek symbols because the Greeks are the guys who kind of came up with the stuff. It's all math that my students know how to do. It's just once I throw in the Greek, they just, like, their brain melts to pudding. And they just, like, I'm so stupid because I don't know how to, I don't know what that symbol looks like. So since I don't know what the symbol is, since I don't know what the symbol is, I must not know how to do the math, so I'm just going to skip it because I'm too dumb to even understand it. And that's total bull. We just do this because we're jerks. And so once I tell you that, once I tell you, hey, look, they're just doing it to mess with you, if you go in and actually apply some brain cells to it, you'll figure this one out. Like, for example, say that A star B equals the square root of A plus B. What is 10 star 6? Okay. Star is not, yeah, you got the answer right off the bat. It's done. Yeah, you figured it out. Star is not a weird, I mean, it's not a math symbol that you use in math. I've never actually seen it as, like, it's not times, it's not this. And they're only defining this temporarily for this one particular problem. So all you do is you take the numbers and you replace them with the letters. Or no, backwards. You take the letters and you replace them with the numbers. So for A, I'm going to put 10, and for B, I'm going to put 6. So 10 star 6 is equal to the square root of 10 plus 6, which is the square root of 16, which is 4. That's it. That's it. Look, I'll make another problem. Oh, dude, this one's super hard. Let's pretend that A heart B is square root of A plus B. Excuse me. What is 10 heart B? It's the same thing. I'm just changing the symbol to mess with your brain. Same thing. You guys got it? And the only reason why I'm throwing in this symbol is to freak you out. Because I'm going to throw in this symbol and see if you actually read the problem. Because if you finish reading the problem, you'll actually be able to solve it, I guarantee it. But the problem is, half the students I know look at this and say, this is way too hard math for me. I've never seen that in math class before. I'm not even going to try it. And they get it wrong. I bet you that happens. Actually, I know it happens. How do I know it happens? Because I hang out with people who write ACTs and SATs sometimes. I once did. All right, let's try one. Let's do another one. What about X happy face Y is equal to X minus Y over X. You guys got it? if 19, or no, not 19, if 9 happy face 4 equals 15 happy face K, what is K? Oh my gosh, that thing looks horrible. It's the most horrible problem I've ever seen in my life. And K is not 4. No, that's not. No. All right, so let's try it. You're saying that 9 happy face 4, right? So you're telling me 9 minus 4 over 4. No, 9 minus 4 over 9. Right? That's what you're telling me? And on the right side, you're telling me 15 minus K over 15. We cool? All I did was I applied the funky little definition they gave us. Yeah, nothing crazy here. All I did is I just replaced the X and the Y with the 9 and the 4. Bada bing, bada boom. And I replaced the 15 and the K with an X, or the X and the Y with a 15 on the K on the right hand side. Am I doing something that freaks you guys out? I mean, I'm downplaying this and I'm saying no, this is easy. It's easy, and I don't want to make you feel stupid because you guys are thinking I'm looking at this and like it's not easy to me. Is it easy for you or what? Is this easy for you or is this? I looked hard because. Yeah. All right. You're right, Sophia. It looks hard. You're gonna find it's not hard. Let me just 5 over 9 time equals 15 minus K over 15. Is it all right with you if I multiply it by 15 up here? Sure. All right, then this is really, I can reduce this because both of them can be reduced by 3. Can you guys see that or is the glare in the way? All right. I can divide the top and the bottom by 3 over here. So then it becomes 5 times 5 over 3 equals 15 minus K. So that would be K equals 15 minus 25 over 3. We cool? All I did was I took the K and put it on that side, and then I took the 25 over 3 and put it on that side. No magic here. 15 over 3 is 45 over 3. Or 15 is the same as 45 over 3. So 45 minus 25 over 3, that's equal to 20 over 3. That's my answer. 20 thirds. Roughly 6.66666. That's your answer. I mean, it's not a pretty answer. It's an ugly answer. But all right, we cool? Again, that one was not hard. It looks hard, I'll admit. I'm fine with you saying it looks hard. I'm even fine with you guys freaking out about it. But what I'm not fine with is you guys not trying it or doing it because you guys think it's hard. All right, let's this one's a good one. Yeah, I'm going to probably cover this section and the next one, and then we'll be good. Good. All right, special triangles. There's triangles, and you should have known this from geometry class, but we can go over this. Remember triangles? You got 3 different kinds of triangles, general triangles at least. This right here is an equilateral triangle. We say that it's equilateral by doing this kind of thing. We put a dash and a dash and a dash over here. Since it's the same dash over here, that's kind of signifying that they're all the same length. Because it's an equilateral triangle, if I were to add up all of the degrees inside of the triangle, what would I get? If I add up all the angles in a triangle, I get 180 exactly. So if that's the case, and you guys know that is true, then each angle inside of the triangle is what? Of an equilateral triangle, that is. 60. 60, very good. Geometry, guys, geometry. All right. The next triangle, I think, is, do you guys know what this one's called? It's an isosceles triangle. Very good. It's like an equilateral triangle, it's just one of the sides aren't the same as the other two. This actually looks like the symbol for Boba Fett. The Mandalorian armor, whatever. All right. One of the things I can guarantee will Barron say about an equilateral triangle or an isosceles triangle is that the opposite, is it the opposite interior? No, that's a different system altogether. That these angles right here are the same as each other. Does that make sense? And then the last triangle I can talk about is a right triangle. And I usually signify the right triangle, the rightness, by that little box in the corner. What is a formula that you guys know about right triangles? Pythagorean theorem, which is if this were A and this were B and that were C, then A squared plus B squared equals C squared. Now, C always has to be the hypotenuse. But I could have switched these. This could be A and that could be B. It could be A and B. It doesn't matter. As long as the C stays as the longest part. Got it? All right, cool. Now, there's special right triangles, and we call these, there's special numbers that go into here that work out. And we call these Pythagorean triples. For example, if A were 3 and B were 4, then C is what? Well, let's see. 9 plus 16 is 25. Take the square root of that, and you get 5. Awesome. If A were 3, B is 4, and C is 5, then you have a 3, 4, 5 triangle. 3, 4, 5. Are we cool? Now, this doesn't always work. For example, if A were 4 and B were 5, would C be 6? A 4, 5, 6 triangle? Hey, a 3, 4, 5 worked. No, it doesn't always work. Does it work in this case? Let's see. 16 plus 25 is not 36. Okay, yeah, it doesn't work in this case. So, I want you to recognize the 3, 4, 5 triangle. You guys think you guys got the 3, 4, 5 triangle? Yeah, all right, cool. Because I'll tell you what, I'm going to spend the next 15 minutes trying to trip you up And I'm going to show you the 3, 4, 5 triangle again. I wonder if you're going to even recognize it. Yeah, there's other triples. There's the, I think it's 5, 12, 13. That's another triple. You can just look it up. There's this whole list of triples. And you don't need to memorize them. I expect you to know the 3, 4, 5. I don't think you need the 5, 12, 13 off the top of your head, but I know that's another one. The 3, 4, 5 is probably one of the most common ones that you're going to see. We cool? All right. There's another triangle. All right, let's talk about an isosceles right triangle. So not only do we have a right triangle, but we have an isosceles triangle. So basically this length is the same as that length. We cool with that? Do you know if this angle is the same as that angle? And what angle are those? Oh, excuse me, a 45. Good. 45, 45, 90. I love it. Awesome. If this were the length 1 and this were the length 1, what would this length be? Use the Pythagorean theorem. No, it's not 2. It's 1.44. Also, probably more commonly known as the square root of 2. Think about it. 1 squared plus 1 squared equals 2. You take the square root of it, because you got the c squared and you want the square c. Yeah, there we go. Yeah, square root of 2. We cool? That's going to rear its ugly head in the next 5 minutes, I promise you. Again. All right. Now this one is probably the least common, maybe the least helpful one, but I'll tell it to you anyway. 30, 60, 90. This is called a 30, 60, 90 triangle. If this is 1, this is 2. You guys know what this needs to be? No, the bottom length. Nope. Yeah, let's go with Cameron's original guess and say, hey, that's 2. No, okay, and this is 1, then this is actually the square root of 3. Because if you think about it, right, like 1 squared plus the square root of 3 squared, which is 3, is 4. That has to be 4. So we're good. Are we cool with that? Now, do you have to memorize this? I would totally memorize each of these. Maybe not this one, but definitely these two. Okay? I think that, and it depends on which test you take. I'm not sure if the EOC does it. I know that for the SAT and maybe even the ACT, they give you all this information at the beginning of the test. And a lot of students forget that. A lot of students, they just don't even use that information. So, anyway. Are we cool? Let me try a problem. All right, here we go. I'm going to have a triangle right here. This is 7. This is 4 square root 2. Here's A, B, and C. And I'm going to tell you that this thing is not drawn to scale. Got it? What is this length? You guys know how to solve this problem? Or fine, I'll tell you, I'll show you how to solve this problem. It's hard to have you guys describe to me what to do. All right, first thing I would do is I would draw this dotted line right here. Completely vertical dotted line. That makes a right triangle and a right triangle. I see two right triangles. The right triangle on the left is oh, I'm sorry. I also tell you that this is 45 degrees. I'm sorry. That 45 degrees is actually in the original problem. All right. So if this is the right triangle on the left, that is a isosceles right triangle. Does that make sense? So what is this length down here? Three and a half? No. Look back on the equation that I gave you. No. No, the hypotenuse is 4 square root 2. I want this length right here. Fine, fine. Maybe I should have written the isosceles right triangle equation like this. Remember, I just had it up on the board. If I put 1, 1, and square root 2. Does that make sense? I just had it like 2 minutes ago up on the board. Maybe I should have written it like this. A, and A times the square root of 2. Oh, good. So the side is 4. Perfect. Perfect. Okay? So what's BC? Oh, yes, you're right. This side is 4. So what is BC? What is this length right here? Seven? Nope. The bottom, AC, is 7. I would guarantee to say that it's smaller than 7. Four? No? All right, fine. I'll draw the picture for you. Ready? This is 4, right? This is the right-hand triangle. What is this right here on the bottom? Maybe I didn't draw it nicely. What is this length right here on the bottom? Oh, it's 3. Right? Because if the whole length on the bottom was 7 and then this part was 4, then this part was 3. Excuse me. Ugh. Yeah, BC is 5. I told you I would trick you guys. I told you. It's a 3, 4, 5 triangle. 3, 4, 5. Ah? Huh? I got you. No. With the 3, 4, 5 triangle, if I know one is 3 and I know one is 4, then I know that the longest side has to be 5. Gerens Boberens. Or, Bradley, you could apply the Pythagorean theorem to this sucker and make it 9 plus 16 is 25, and 25, the square root of 25 is 5. Yeah, 5. 3, 4, 5 triangle. I'm telling you guys, learn it. It will save your lives. All right, here we go. I'm going to do another one. These are good. Say that I have a triangle and R is at 0, 0. And S is at 9, 12. What is the distance between R and S? So I didn't tell you a triangle, actually. I take that back. This is just a coordinate problem. R is at 0, 0. S is at 9, 12. What's the distance between R and S? I hate these problems. All right, fine, Lucas. Right. The distance formula sucks. I agree with you guys. Yeah, you're right. No. Don't use the distance formula. All right, fine. You can use the distance formula. I always forget it. Just like Sophia. I agree with you. Why don't we try plotting this thing, all right? The ugly plot, right? We don't need to make a super nice one. 0, 0. We cool? 9, 12. The other point is right here. 9, 12. We cool? Here's 0, 0. So the distance is, I'm looking for this length right here. Do you see a triangle? Ah, there we go. I do see a triangle. It's right there. It's a triangle where the bottom part is 9 and this guy's 12. Then what is this? I'll tell you what it is. It's 15. Let me just double check to see if that's the right answer. I think it is. Yeah, it's 15. Yep. The square root of 345 is 15. How did I get that? How did I get that so quickly? How are you so awesome, Mr. Dalday? All right. I'll tell you what. 9 and 12 are kind of related to each other. Right? Like if I were thinking about simplifying them if they were a fraction or finding the number that is common in between them, what would you do? Yeah, all right, you divide by 3, right? So this is 3 times 4, and this is 3 times 3. I'm betting that this is going to be 3 times 5. You know why? You want to know why? Because 3, 4, 5, baby. 3, 4, 5 all day. I don't know. I'm feeling goofy today because my voice really hurts and I'm just like out of it. So 3, 4, 5. Multiplied by 3, of course. This is also a 3, 4, 5 triangle. It just happens to be scaled up by a factor of 3 on every number. Oh, excuse me. All right, let's do it. How are we doing with that? How's your brains? Can you guys take some more of this? We can stop now or we can keep going. It's up to you. We can stop now because usually I stop right about it. Well, no. Yeah. Yeah, you said you need practice. Well, I'll give you some good practice. You want to know good practice? Take a bunch of SAT and ACT tests. Just take a bunch of them. And guess what? I'm assigning you a bunch of them as homework. Ah. You just got to do them a lot. That's what you got to do. All right, cool. But these lectures are basically me recapping all of Algebra 1 and Algebra 2. Now, if you guys do poor on Algebra 1, or if you guys do poor on the SAT and that kind of stuff, on the ACT, and I look at your scores and I look at like where you did poor on, a lot of this stuff is geometry and Algebra 1. So I'm saying I'm not taking credit for them. I taught them Algebra 2. That was all Algebra 1 stuff. And it really was. So, anyway. But if it's an Algebra 2 thing you got wrong, then you know, I mean, that's my bad. I didn't teach you well enough or whatever. I think I did a pretty good job. All right, let's see. Okay, here's a good one. When you divide, here, let's do a remainder problem. When you divide, when n is divided by 7, it gives you a remainder of 4. When n or what is the remainder when 2n is divided by 7? 2n divided by 7 gives you a remainder of what? You guys understand the question? All right, I'll read the problem. When n is divided by 7, the remainder is 4. What is the remainder when 2n is divided by 7? Okay, here's what you do. The hard part about this problem, I'll tell you what the hard part is. You're trying to think of every single possibility for n that's in your head, right? You're trying to think of, well, let's solve this for every general n state I can think of. And I would say this, all right, well, if it's too hard to think about in terms of variables, let's plug in numbers. Tell me a number, when I divide it by 7, I get a leftover 4. 28. Is that 28? No, wait. 7, 14, 21, 28. No. I want to divide your number by 7 and have 4 left over. $11. Good. 11. 11 divided by 7 gives me a remainder of 4. We cool? Then, what is 22 divided by 7? What is the remainder there? It's 1. Right? Yeah. So what's the answer? The answer is 1. And you're thinking to yourself, I know what you're geeking out about. You're thinking, wait, you just did every single n in your head? Because in my book, you only did one case where n is equal to, this thing doesn't work. Right? And I would say this, well, fine, let's choose a different number. Like, let's say 18. 18 divided by 7, if n is, so this is let n equal 11. And over here I'm going to say let n equal 18. If n were 18, then it's a viable n. I'm allowed to choose 18, right? Okay, sure. I'm allowed to choose 18. Well, what's 36 divided by 7? That's 5. Remainder 1. The idea is this. If they gave me this rule, then there's only certain n's I can choose. I can choose n equals 11, or 18, or 25, or 32, ... and so on and so forth. I could choose any of these. But all of these properties, but I'm only going to choose one of them because they all have the same properties. Does that make sense? No, I'm not. I'm not choosing random ends. Oh, okay. Well, Sophia, what you're asking is how did I get these numbers in my head so quickly? Are you that much of a genius, Mr. Dalde? Is that what you're asking me? I know what you're saying, Lucas. I don't know how it pertains to what you're telling me. All right, all right. Um, Sophia, the way I got this list of numbers in my head so quickly was I started off with 11. That's not hard to do. Then I added 7 to it, 18. And then I added 7 to that number, 25, 32, 39, 46. I just kept adding 7 all the way across. These are my list of ends. Ends is allowed to do this. Because I know that 7 times 1 gives me a remainder of 4 here. But 7 times 2 is 14, but it still has a remainder of 4 here. And 7 times 3 is 21, and you add 4 and you get 25. So I just added 7. That's how I got my numbers. But what I'm saying is you don't need to add, you don't need this whole list of numbers. None of these matter. You just need one of them. This one right here. You just need one of them to see how the properties work because the same properties hold for all the rest of them. Excuse me. All right, wait. I still hate coming up with a list of numbers, but you don't need the list of numbers. You just need one of them. And Cameron came up with this first one. In fact, it's the easiest one to think about because you just go, well, 7 plus 4 is 11. I think that what the problem here is you need practice with this, right? And it's kind of freaking you out because you're saying, well, that's fine and dandy, Mr. Dalda. You can do this because you're freaking amazing at math and you can look at these problems and just say, well, this is the way to go about it. But how am I going to do that when I'm taking a test? Is that what you're thinking in your head? I can read your mind. Yeah, totally. All right. Well, I'm good at this for 2 reasons. Because I've had a lot of experience with this. And I had a lot of experience with this when I was your age. I did really, really, really well on the SAT math. Not because I'm a genius. I'm actually quite dumb. But what I did was I practiced a lot of it. I just sat down and did like 10 SATs before I actually took the SAT. I just did a bunch of these problems. That's what you do. And a lot of this stuff that I'm teaching you isn't coming from like a textbook. This is just coming from over the years, I've experienced math in this way. Let me show you how I do it. It's just the easiest way I came up with. It might not be the easiest way. It might not even be the best way. It's the way it works for me. Are they changing the SAT this year? They might. I'm not sure. I have to get back to you on that. And here's my answer to that. Yeah, but math hasn't changed in the last 400 or 500 years. If you're good at math, you're good at math. You know what I mean? They might ask you a different style of questions, but I'll tell you what, I saw a book downstairs that says the revised SAT or whatever. I'll go grab it and see if I can try out some problems from that one. Cool? Because this book that I'm using right now is like a little bit old. All right, here, let's try this one. A bracelet is made of colored beads in a repeated sequence. Roy G. Biv. So, apparently I put red, orange, yellow, green, blue, indigo, violet. Red, orange, yellow, green, blue, indigo, violet. So I'm just keep on making a bracelet, and I keep on putting different beads on it, and I put it in the order of Roy G. Biv. Got it? The first bead is red. The first bead is red. The last bead is yellow. All right, so let's... First is red. Last is yellow. What is the possible number of beads on the bracelet? Okay. So here's the options they gave us. Is it 48 or 49 or 50 or 51 or 52? How many beads are on this bracelet? If it's the first bead is red, the last bead is yellow, how many beads altogether? Pretty cool? All right. Here's what I would say. Roy G. Biv. What you could do is you could say, wait, the first term is red, is 10. What are you talking about, the first term? No, I'm asking which one of these numbers could be on the bracelet if the first one is red and the last one is yellow. Is it 45 or 48, 49, 50, or 51, or 52? We cool? How are you supposed to know? All right. Yeah. You put beads on a bracelet, Roy G. Biv. First one is red, last one's yellow. How many beads are on there? Yeah. No, they totally gave you enough information. This one's a tough one. This one is a tough one. I agree with you. You guys are all freaking out. Well, here. Okay, all right. No, I think I see what you mean, Lucas, is you're saying you could have 10 beads on the bracelet, right? You could have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We cool? Is that what you mean? I see what you mean. All right. I get it. Okay. Because even though 10 wasn't one of our options, does that make sense to you, 10? All right, good. So I have a question now. Like, I would literally draw this table. I have a good way to start telling you, try and think about it like this and think about it like this, but here, let me do this then. Would you guys disagree with me if I said this is 14, 21, 28, ... Or do you agree with me? Yeah, all right, fine. Right, because the pattern repeats itself every 7 beats. So this is actually going to be multiples of 7. We cool? Whoa. Which one's a multiple of 7 that gets me closest to these numbers? Would you say 49 is going to be in here? Yeah, all right, cool. Then This one's going to be 50, 51, and 52, right here. If 49 is here, then 50, 51, 52. Answer's 52. Did you say no sense? Now this one takes a little bit of thought. I mean, I could show you a crazy mathy way to do it, but it just takes a little bit of brain cells on this one. I drew the table to kind of do a little bit more. Why would they test us on stuff like that? Well, I used to look at job listings, and I used to look at, for different jobs. And one of the interviews I went on was a job for like a web programmer or something like that. And the way they advertised it, they said, "Are you good at solving math problems?" And I said, "Yeah, I'm good at solving math problems." That's the title they gave it. "You good at solving math problems?" I said, "Yeah, I'm good at solving math problems." And I went to the interview and all that kind of stuff. And they made me solve all kinds of stuff like this for the interview. It was horrible. Actually, I enjoyed it a lot because I love solving math problems. Why would they do that? Well, because this takes thinking outside the box. Actually, funny enough, this takes thinking inside of a box. For this particular one. But this takes creative problem solving, and that is the kind of people that they're looking for that particular job programmer. So when they, what is it? Static? I don't understand. I don't understand you. All right. Yeah, this takes creative thought, and that's the kind of stuff they're looking for when you're solving real world problems, is to think outside the box, or actually in this case inside the box. Yeah, no, I agree, but you get good at doing these creative thought problems as you get more experienced. Think about what the heck this test is for. I mean, your generation is taking more tests than I did, for sure. Right? Yeah, but why do the college care for us? Care about it? Your generation is taking way more tests than I did. You guys are tested the hell out, right? Why? You should be asking why. What's the point of doing all these tests? The answer is, well, they gave you the ACT and the SAT so that they can measure your ability to do well in college. Does it actually measure your ability to do well in college? I don't necessarily. I'm not going to speak to that. I don't think so. I think it measures how well you discipline yourself in practice and get good with tricks like this. That's what it really measures. That's why I'm spending a couple weeks doing this, so that way you can do well in the SATs. It's not necessary that you're, great at math. It's just I'm showing you all the tricks. But something like this is a good problem because I would say you might not see a problem like this in the real world math problems, but you will see problems like this in physics or chemistry or biology. Or if you become a doctor and you need to figure out something that no one's ever done before. Those kinds of things. This is a problem solving. And problem solving is what you need to do, my friends. Bradley, you want to be an anesthesiologist? Yes, everything needs to be done by the textbook, but there might be a situation where the textbook doesn't apply. In that case, you need a creative solution, my friend. Well, what if your person has a special disease that eats up that raises their metabolism beyond what normal people have? That goes outside of your equation. You got to be the guy who deals with it. All right, maybe I think we're done because what I'm doing is I'm showing you all of the hard ones and showing you my tricks for solving them. Not all the problems on the textbook are like this. These are just the hard ones. If they were easy, I wouldn't have gone over them in class. So I think you guys are freaking yourselves out. You guys are thinking, oh my gosh, this is the hardest test ever. I don't think I can ever do it. Blah, blah, blah. All right. Don't freak out. So I'm going to stop because I don't want your brains to explode. All right. Yeah, it's end of class time anyways. What's your thoughts? Are your brains all right? You guys all right? All right. Wait, Bradley, why are you mad? I tend to do that to you, huh? All right. I agree with you in saying that maybe you should be mad because you're taking a whole lot of tests. And I don't think that tests measure your intelligence. I think that tests measure your ability to take tests. And believe it or not, I for one am horrible at taking physics tests, even though I'm a physics major. They freak me out. I like math tests. They're like puzzles to me. But physics tests freak me out, man. And I'm a physics major. All right. Yeah. All right. Well, yeah, I agree with you. When you step back and really think about it, I don't know why you're taking all these tests. But at the same time, that's what schools take. So it's a necessary evil that you're going to have to get over, my friend. Sure, you can fight the system all you want, but you're not going to get into college without taking it. Which, of course, might be the wrong attitude to take, right? I might be the guy who's saying, look, just go with it. Don't rock the boat. But then you're the guy who's saying, no, it's wrong. And it actually is wrong, and I agree with you, but I'm just saying don't rock the boat. And then nothing ever gets changed. So I don't really have an opinion on these tests whatsoever. But if you're going to be forced to take them, I'm going to show you how to take them. All right, fine. Be mad, Bradley, and that's cool. I'm cool with that. But you're going to be forced to take them. For now, at least. And if you're going to be forced to take them, I'm going to show you how to do well on them. Are you calmer now? All right. We'll leave it at that. Talk to you later, my friend.